So now that we've gotten our feet wet with some examples of hypothesis tests for a proportion, we're going to repeat the process for tests involving a population mean. Now the method here is going to be practically identical to what we saw in the last lecture with proportions. The only difference will be our test requirements. In this case, we're going to require that the sample size has to be at least 30, or the underlying population has to be normally distributed. And our test statistic formula will be different. So looking at our scenario here, we're talking about weights. So while the sample size is small at just 19, it's reasonable to assume that a physical property like weights will be normally distributed. So we're okay to keep going with our analysis. Now notice that this statement here has the same three key features we saw in the last lecture. There's information about a sample, there's a required significance level, and there's a claim based on what we believe the actual value is. So our claim here is that the mean is 0.8535 grams. And since that has equality in it, it will also be our null hypothesis. And for the alternative hypothesis, I'll use mu is not equal to 0.8535. That should have been a 5 there, not a 9. Okay, and I'm going to use not equal since the description doesn't have anything that would lead me to believe that the company is only concerned about values that are over or under the required size. So now we can calculate our test statistic using the formula for testing a mean. T equals x bar minus mu over the square root of s over n. So I need to pull some values here. X bar is the sample mean, that's 0.8635. S is the sample standard deviation, that's 0.0570. And N is the sample size, that's 19. So if I put all these values in here, I get 0.8635 minus 0.8535 over the square root of 0.057 over 19. Now my calculator tells me this is 0.7647. Okay, now notice this is a t-score rather than a z-score, right? Whenever we're talking about means, we're going to be using a t-distribution, not a normal distribution. So next, I need to calculate the p-value. Now, our null hypothesis is not equals. So I'm looking for values both above and below the claimed value, which makes this a two-tailed test. So the probability I need is the probability the absolute value of t is greater than 0.7647, and so that I get both tails. Right now, going to Excel or a table or whatever method you prefer to calculate probabilities, this comes out to 0.4543, and this is greater than our alpha value, which tells me that the likelihood of the variation that we're seeing being caused by chance is pretty high, or at least higher than our tolerance level. So we won't reject the null hypothesis. And the null hypothesis and the claim are the same. Right? They both involve equality. So since I didn't reject the null hypothesis, I'm also not going to reject the claim. And now to finish this up, right, to make my final conclusion, I would say there is not sufficient evidence to reject the claim that the average weight is 0.8535 grams. Right, and that's it. That will be my final conclusion. Now, if you want to approach this using the critical value method, which would be your only option if you're working from a t-distribution table, since those only give you t-scores, not probabilities. Right? To find the critical values, you need the t-scores that give you 0.05 total in these two tails. So that's 0.025 in each one. Again, you go to Excel or a table, whatever you prefer. This comes out to 1.734, and the left side would be negative 1.734. Right? And if we put our t-score in here for comparison, our t-score is over here somewhere, 0.7647. So because our test statistic is outside of the critical region, that means we would fail to reject the null hypothesis, which is the same conclusion that we got using the p-value method. Okay, so that's how we test a hypothesis for the mean, and we've also seen how to do a proportion. So we're almost to the end of the course here, and our last topic is going to combine descriptive statistics with inferential statistics. We're going to be looking at something called correlation, right? And the idea here is if I have two variables and they're paired up, I have heights and weights for elementary school students, for example. How can I tell if there's a relationship between the two? Does a high height correspond to a high weight, for example? Right? That's what we're going to talk about in the last couple of lectures here. First, we're going to talk about how to measure correlation. Then we're going to talk about how to describe the correlation, and then we're going to circle back around to these hypothesis tests and look at how we can do a hypothesis test to determine if there is sufficient evidence to conclude that a correlation exists between the two variables.